Chapter 7.4 Integer Exponents and Scientific Notation. Okay, there are more properties related to integer exponents. Okay, first of all, x to the 0th power. X to the 0th power is always 1. Always 1. We will assume that the base x is not equal to 0. So something to the 0th power is always 1. So for example, okay, let's say the parenthesis contains the base. So maybe x cubed, y to the 4th power, and z. And this is raised to the 0th power, then this is equal to 1. Because the exponent is 0, so the result is 1. Okay, and there's another property which is, let's say x to the negative 3rd power. The exponent is not negative integer. Then you can move this one. Okay, this is actually equal to, this is the numerator and the denominator is 1. So you can move this x cubed, x negative 3rd power to the denominator, then the sign of the exponent changes. So whenever you move an exponential form from numerator to denominator or from denominator to numerator, make sure you change the sign of the exponent. So if we have something like this, x to the 5th power over x cubed. Okay, now x cubed is in the denominator, so once we move this one to the numerator, then it becomes x to the negative 3rd power. So by definition, we can add the exponents. So 5 minus 3, so that equals x squared. So we can use this property to simplify the exponential expression. Okay, actually this means the numerator contains 5x's because x is raised to the 5th power, and the denominator contains 3x's. So we can get rid of 3x's from each side. So you can remove 3 from the numerator and denominator, so the leftover is x2. So what we can do is just move one of the exponential form from denominator to numerator, and then you can simplify. So the rule is this: x to the nth power over x to the mth power. Then you can move the denominator to the numerator. Then there will be x to the nth power minus n, because this n becomes minus. Or if you want to move the numerator to the denominator, then the numerator becomes 1, and the denominator is, the exponent is m minus n, because this positive m moved to the denominator, so it becomes minus n. Okay, using these 3 properties, let's try some examples. Okay, this rational expression contains, the numerator contains negative exponent. So why don't we move the numerator to the denominator? Because negative 3 is less than 2. So always it's better to move the smaller exponent. Then this will be, okay, so the numerator becomes 1. The numerator is 1. So the denominator is 3 squared, and then move negative 3 to the denominator, then that becomes positive exponent 3. So this is equal to 1 over 3, and then add the exponents, 2 plus 3, so that is equal to 1 over 3 to the 5th power. Then 3 to the 5th power is, that is what? 3 to the 4th power is 81, so 81 times 3, that will be 243. Okay. Or you can use mental math. Mental math is this. So move the numerator down, then 3 to the, okay, 2 minus 3. So 2, negative 3 becomes positive 3, 2 plus 3. So that is equal to 1 over 3 to the 5th power. So that is 243. Okay, let's try another example. Okay, exercise 2, letter A. 8 to the 7th power times b cubed. This is negative 7th power. So we can move this negative 7th power to the denominator. so the numerator b cubed stays, but move this a to the 7th power. So the denominator contains a to the 7th power because this negative exponent becomes positive. Okay, letter B, x to the negative 4th power, y to the 6th power divided by xy squared. Okay, now we have x terms in the numerator and denominator, x factors. So we can move this minus 4 into the denominator because 1 is greater than negative 4, and negative 4 is smaller than 1. So move it down. Then, okay, that is, okay, how about the y? Okay, y is, okay, 2 is smaller than 6. So let's move this one up. And then this one down. So the numerator will be x to the 6th power. Move y squared to the numerator, then the exponent becomes minus 2 over. Okay, let me rewrite it. So y to the negative 2nd power, because we moved y squared to the numerator. And then the denominator is x. And then move the numerator x to negative 4th to the denominator. That will be positive 4th power. So finally, y to the 6 minus 2 over x to the 1 plus 4. So y to the 4th power divided by x to the 5th power. Okay, why don't we just use the mental math? So move, okay, for the numerator, okay, move 2 to the numerator, then it will be y to the 6 minus 2 because 2 becomes minus 2. How about x? Move the numerator to denominator, then the denominator exponent is 1, and then change the sign of negative 4, so it will be plus 4. So y to the 4th power divided by x to the 5th power. Okay, let us see 6 times d to the negative 4th power. When we simplify this expression, always make sure the exponent should be positive. So from here, you can leave x in the numerator, move d to the negative 4th power to the denominator. So it will be d to the 4th power. That's it, simple. Okay, exercise 3, letter A. Okay, let's simplify this. So before we do this, let's reduce numbers. Okay, 35 and 25, they are both divisible by 5. So divide 35 by 5, then there will be 7. And 25 divided by 5 is 5. Okay, how about A? So we have the factor A has exponent 6 and negative 2. So since negative 2 is smaller than 6, let's move negative 2 to the numerator. How about the exponent of B? Or negative 2 and 5. So this time, move negative 2 to the denominator. Okay, then the result is negative. The numerator contains 7, denominator contains 5. And then A becomes, the exponent A is 6 plus 2, because negative 2 moved to the numerator, it becomes positive 2. And then B, move negative 2 to the denominator, so 5 plus 2. So this is equal to negative 7 a to the 8th power divided by 5 b to the 7th power. Okay, letter B. Okay, the first one is negative 2x, so leave it as it is. And then we will simplify the second exponential form. So this means there are two terms in the base, 3 and x to the negative 2nd power. So let's separate each factor in the denominator, So negative 3 raised to the 3rd power, and then x to the negative 2nd power is raised to the negative 3rd power. Okay, in this case, we use this formula. A times b, the base is a product, and raised to the nth power. Then assign this power n to each factor in the denominator, in the base, a and b. So a to the nth power times b to the nth power. This is what we did, what we used. And then simplify each factor. Okay, 3 to the negative third power is, okay, this is equal to 1 over 3 cubed. And this part is multiply the exponents, -2 and -3, because this is power to another power. So if the base is a to the nth power and raised to the nth power, then the result is a to the n times n. Multiply the exponents. Okay, now reduce it. So the numerator is, okay, the result is negative. The numerator contains 2x. The denominator is 3 cubed. And then we have the third factor, which is x to the positive 6th power. So this is equal to -2x to the 1 plus 6. And then the bottom is 3 cubed, which is 27. So finally, this is equal to -2x to the 7th power over 27. Okay, next topic is about scientific notation. Okay, scientific notation is written as this: a number, some number a multiplied by 10 to the nth power. And in this case, a is between 1 and less than 10. So a should be the number starting from 1.000 all the way up to 9.999 and so on. So a should be one non-zero digit, always one non-zero digit. That is the range of these a values. A cannot be equal to 0 point something, or a cannot be equal to like a 10 point something. So always a has to be one non-zero digit. Okay, so based on this, let's try some examples. Okay, we want to write this number in scientific notation. So first of all, let's get the decimal point is actually at the end. And then let's count the number of places that we move the decimal point to the first non-zero. So in this case, between 8 and 2. So we want to move this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right after the first non-zero digit, which is 8. So we moved 11. We moved 11 places. So we can write it as, okay, 8 point. This should be 8.243 because we moved the decimal point to the first non-zero digit and multiply by 10 to the nth power. This n is 11 or -11 because we moved 11 places. And then should it be -11 or +11? This is important. Okay, we want to make this number large so that it will be, this number, very large number. So in order to make a large number, the exponent has to be positive. So it will be 10 to the 11th power, not -11th power. If the exponent is -11, then we are making this number smaller. But actually we want to make this number large, really large. So the exponent has to be positive. Okay, this one has to be positive. Positive to make the number large. Make it large. Okay. All right, let's try another one. Okay, this number is really small, so let's move the decimal point to the first non-zero digit, which is between 9 and 6. And then let's count how many spaces we moved. 1. Okay, let's use red color. So 1, 2, 3, 4, 5, 6, 7, 8. So we moved 8 digits, 8 places to the right. Okay, right or left, it doesn't matter, because when we write this scientific notation, the number should be 9.61 times 10 to the nth power. This time this will be 8 or negative 8, but this time it should be 8, negative 8, because as I mentioned earlier, this number 9.61 should be very small. So this number will be 9.61 should be multiplied by something so that the result will be very small. So in order to make this one small, the exponent must be negative. So exponent, the exponent is negative. Is negative to make the number very small, very small. Okay, exercise 5 is to write the number in decimal notation. So this is scientific notation. So when we write this, okay, this number, now this 7.329 is multiplied by 10 to the 6th power. The exponent is positive, so we are making this number large, very large. That means we will move the decimal point 6 digits, 6 places. So in order to make this number large, the decimal point must go to the right. So let's move 6 places to the right because we want to make it large. So let's put a little bit more zeros. Since we need 6 places to the right, we have 3 digits with 329. So we have 3 digits, so we need 3 more digits to make it 6 places to the right. So move from here 1, 2, 3, 4, 5, 6. So the decimal point moves here. We moved 6 places to the right. So put commas after 3 places. So this is the number. Okay, how about B? Okay, 6.8 times 10 to the negative 10th power. The exponent is negative. So we want to make this number small. 6.8 will be small and small and small. So in order to make it small, the decimal point should move to the left. So from here, let's put 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and write 6, 8. And then move the decimal point 10 places to the left because we want to make it small. So move to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the place where the decimal point should move. So we moved 10 places to the left. Okay, exercise 6, letter A. This is multiplying or dividing, scientific notation. So this is a product. Product means multiply everything. So we can add the numbers 3 and 1.1. Also we can multiply the exponents. So 10 to the 5th power and 10 to the negative 8th power. And once we multiply the numbers 3 and 11, that is 3.3. And then the exponential forms. We have 2 exponential forms, same base, which is 10. So we can add the exponents. One is 5 and the other one is negative 8. So this is equal to 3.3 times 10 to the negative 3rd power. So we can write the answer in scientific notation like this, or you can write it as just a number. So you can put 3 zeros in front and then move the decimal point to the left because we want to make 3.3 smaller because the exponent is negative. Okay, letter B. Okay, 7.2 times 10 to the 13th power divided by 2.4 times 10 to the negative 3rd power. Okay, let's check the number. When we simplify this, let's check the number. 7.2 divided by 2.4 isn't it 3? 2.4 times 3 is 7.2. So this will be 3 multiply by 10 to the 13th power, and then move the decimal. Okay, so let me cross this out. So this will be 1, this will be 3. Since this negative 3, move this one up. Then there will be 13 plus 3. So this is equal to 3 times 10 to the 16th power. So this number is really large. So let's leave it as it is.